So our first question is, we have been given that one of the roots of the equation x squared plus 6x minus 9 minus k equal to 0 is 3 times the other. Find the roots and the value of k. Now, when we are dealing with the roots of equations, and this is one of the topics in algebra.
We are not seeing that screen. We are still on the first screen.
Okay. Let me share again if you're not seeing.
We are still on the first.
The first one.
Okay.
I'm going to repeat the sharing. Can you see now?
It is there now.
Okay, thank you. So,
yes, we can.
Okay, as I was saying, is that when we are looking at roots of quadratic equations, there are key concepts that we should take up from there. First of all, from this equation, we have the one I'm underlining. We have what we call sum of roots, sum of roots and products of roots. So the sum of root is negative of the coefficient of x. Meanwhile, the product of roots is the constant. And for our case, our constant is negative k, which means the sum of root will be negative k. I mean, the sum of root will be negative 6, and product of roots will be negative k. And given the equation x squared plus 6x minus k, we can let one of the roots be alpha. And by the statement up, they're saying the other root is 3 times the other. So it means the remaining root will now be 3 alpha. So now, when this is 3 alpha, the sum of roots becomes alpha plus 3 alpha, which is negative 6. And alpha plus 3 alpha gives us 4 alpha. And when we solve for alpha, we shall get alpha to be negative 3 out of 2. So from here, assuming the roots were alpha and beta, then we shall have alpha plus beta equals to negative 6. And when you are handling roots of quadratic equations, the first thing you must do is to extract the roots, the sum of roots and product of roots, before you can use them to solve a given problem. So it is important that a student must know how to extract. And as we said, the sum of root is usually negative coefficient of x. But before you can do that, you ensure that the coefficient of x squared is 1. If the coefficient of x squared is not 1, you need to divide all through by the coefficient of x squared. Then later you extract your sum of roots and products of roots. On the other hand, the products of root will be alpha, beta. And in this case, alpha beta will be equals to negative k. And that's why in solving this problem, we have sum of roots equals to negative 6. And from this, we straight away get the value of alpha. Now, after you have got the value of alpha, you can proceed to get, you can now proceed to get the other, you can proceed to get the other roots. The roots will be 3 out of 4 and negative 3 out of 4 and negative 9 out of, negative 3 out of 2 and negative 9 out of 4. So these are the roots, and that is the first part. And the second part requires that we should determine the value of k. And the value of k is got from product of roots. Initially, I represented them by alpha beta. So alpha beta equals to negative k. But now, beta is 3 times alpha. That's why we have alpha times 3 alpha equals to negative k. We already know that alpha is negative 3 out of 2. And again, when we multiply by 3, we get this equals to negative k. And solving for that, we get k to be 27 out of 4. So that is for part 1. But what I want to advise is that this is one of the easiest questions in paper 1 under algebra. And once it comes, don't leave it, just do it. You will get. What you need is extract the roots, the sum of roots and products of roots. And from there, you can now analyze the problem as given, then you determine what is required. So that is for part A. Then part B, we have, for part B, we have been given that x, if x is so small that the cube and higher powers can be neglected, we should first, we need to find the first 3 terms of the expansion, square root of 1 plus x over 1 minus x. And when you look at this expression, it is a quotient. And for expansion, when given without mentioning any of the expansion methods we use, it means one of them you can use is the binomial, which is the most common. We have other expansions that we have not talked about here. We have Maclaurin's expansion also, but this one requires you to use binomial. Why binomial? When you look at each term in both the numerator and denominator, they have binomial terms. Binomial means 2 terms in an expression. So for that matter, before you can apply, you need to simplify this further. And we know from indices, root of a number is the same as that number raised to power half. And when we expand further one of the properties, this will be 1 plus x to power half divided by 1 minus x to power half. Now we rationalize, looking at the conjugate of the lower number, that is x minus 1, being x plus 1, we multiply both numerator by denominator by the conjugate of the lower expression. And for that case, you can see that the upper one will simply give you x plus 1. Meanwhile, this becomes difference, almost difference of 2 squares, which will give us 1 minus x squared to power half. And when we use the laws of indices again, we take the lower bracket up and the power changes to negative. And that's how the negative a half has come. So the first bracket, that is x plus 1, is now simple. We only have the task to expand the second bracket, which is x minus, 1 minus x squared. And for this matter, we shall have to work on this using binomial expansion. And for binomial expansion, when we consider 1 minus x squared to power half, recall that they have said the cube root and higher powers can be neglected. So in that case, we can consider the expansion for 1 plus, let me use y, 1 plus y. When we raise this to power n, we shall get this to be equal to 1 plus n x plus n times n minus 1 x. Oh, I mean, this is y, not x. This is y. Then this will be y again squared out of 2 factorial plus other terms. So from here, our y is negative x squared. So when we do substitute in this expression, we shall get the first term being 1. Then the second term will be n. Our n is negative half, and our y is negative x squared. Plus the next term will be negative a half for n, then negative 3 out of 2, which is n minus 1. Since our n is negative a half, when we take away 1, we remain with 3 out of 2. Then negative x squared. Then this would be, this would be over 2 factorial. Sorry, I left out this term. But this term, when we expand the power of x, which is already squared here, it goes to x to the power 4. And in the question, you can remember that they said the cube and higher powers can be neglected. So we only remain with it 1 plus x squared out of 2. Out of 2. 1 plus x squared out of 2. Then we need now to multiply this. And when we multiply, this still remains x squared out of 2. When we multiply, we shall have 1 times 1, which is 1. Then 1 times x, which is x. Then 1 times x squared out of 2. We get x squared out of 2. There is no need now to multiply x by x squared out of 2, because it will give us power of x being 3. And yet we already know that power should be neglected. So our expansion will simply be this. And this is the expansion they want. And then there's yet another point to note, or another part to determine out of this. But what I want to say is, for binomial expansion, where you have rational functions like this, you need to simplify before you can apply. In some cases, you may expand all the 2 terms, but in most cases, it may give you a simple, one of them to be a simple number or a simple expression. So leaving you with only the expansion of one of them, like you saw in this particular case. However, it does not matter. If it is requiring that you do both, you need to do and later multiply, like we did for this. So that is for this particular number, how to expand this using binomial expansion. And when the first term here is 1, it's simple. If the first term is not 1, there is yet another formula that you should use. So you need to be careful. Not all the binomial expansion should be in this form. It is using this formula is simply when the first term here is 1. So let's take note of that. Then this question is not done. We still have another part to answer. And that part to answer is now when you have been given a value of x. For example, here they have given us that we should use x equals to 1 out of 17. So when we put x equals to 1 out of 17, this is now 1 plus 1 out of 17 divided by 1 minus 1 out of 17 equals to, on the right hand side, we also substitute for the value of x. So when we substitute for the value of x, we get 1 plus 1 out of 17 plus 1 over 17 squared divided by 2 plus other terms. Now we expand, simplify this. We also simplify the left hand side. It will give us 18 out of 16, but we know 18 is 2 times 9. Square root of 9 is 3, square root of 16 is 4. So that's why we have them out. Then on the right hand side, we have 613 over 578. And from here, when we cross multiply by 4, then divide by 3, and then again simplify, it gives us now the what? The answer they are saying we should show. So here, don't even force stuff. What you need to do is simply to work out from the values provided. Then you do the simplification, then it will come out to the required number. In many cases, students have challenges, especially when it comes to this part. But from my presentation, you can see things will just come out by itself. What you need to do is be patient and you simplify your work correctly. Then things come out. So this is yet another part of algebra. Remember, previously, the other week, last week, I told you algebra is one of the topics which does not miss. And they usually have more than 2 questions, at least 2 questions coming from there. So if you have practiced and perfected yourself there, you will be sure of your full marks. So that is for number 1. And our number 2 is coming from geometry. Geometry, we are required to find the equation of the chord joining 2 points on a curve, and the coordinates of the points are given. Point A
Sorry, Mr. Opio is getting back. He has gotten some network issues. So let's give him some few minutes as he gets back online. Sorry about that. But he is coming back. Just give him a minute. We want to welcome all the schools that are joining. I'm happy to see the teachers on the call. Teacher Peron, you're welcome. So let's give him just a few minutes as he gets back. He's having some. So Teacher Peron, is it fine for you to be sharing with us some tips of passing paper 1 as we get Teacher Opio back?
Okay, thank you, sir. Good afternoon, good evening to everyone. Paper 1, what I can tell the candidates. 1, you have to choose the, like for example, section B, you have to choose the numbers which you are familiar to, so that you first attempt those numbers, then maybe you go to the next numbers which you are not conversant, but you have to attempt the number. And then 2, students have a habit of, if he's writing is giving the answer the same way that that person was given the answer in the book, yet we are answering the paper, and maybe someone marking may not have time to read all through the work that you have written. Summarized work, not presenting the same work as they were given in the books. Maybe another thing that I can tell these candidates is that Mass 1 majorly, what I learned about it is made up of calculus. So if a student is not familiar with calculus, then he will find issues, or she will find issues with that paper. So I urge the candidates that after we have finished the mock, check yourself if you are not conversant with calculus, because you'll find that it is consisting like 50% of the paper. Meaning that if you are not aware of the differential equations, one becomes somehow tricky. But when you are familiar with those major topics, the integration, when you are sure that any method of integration you can apply in, and then you are sure that any differential equation you can attempt, any method of solving a differential, and maybe any differentiation, any method you know, then you are good to go that you can get higher marks in that paper. And then the students also need to practice those proof calculations of trigonometry, because they always appear every the other day, every the other time. So they have to always also be sure that they, at least someone should know how to prove those different those trigonometric functions, and you cannot prove them. Sometimes it becomes hard to prove those questions in the paper. So students must have extra work on those calculations so that they be familiar with any technique that could be in that calculation, so that whenever they are given that question, then they are able to attempt the numbers. Then another thing that I can urge candidates, they should not have bias on some numbers. You find that the student, when you talk about a certain topic, then that person runs away completely. If you want to get some good marks in a paper, like for example, Mass 1, you make sure that that number, I mean, any topic in Mass 1, you are familiar with it. If they say that it is maybe conic section, say, oh, this is simple. Then at least that confidence that you gain before entering the paper, can make you excel in that paper. But if you find that when they talk about some topic, then you run away, it means you will lack the confidence to attempt a paper because you are entering in the paper without confidence. You know that there are some numbers that you can't attempt, meaning that if you reach in that paper and you find that the numbers that you are fearing are occurring maybe in section A or in section B, then it means automatically you lose confidence. And when someone loses confidence in a paper, then there is a higher chance of that person failing that paper. So I urge candidates that they should always leave, don't have any negative attitude towards any topic, towards any number, such that when a paper, when you are to enter, even if you don't know, but if you have that confidence that you can really get that D1 or that D2, and then you will get it because you are already confident before entering the exam. Then you should have calculations several times because math 1 is all about calculating. If you leave the calculation and maybe you for some time, then it becomes hard. So they should have constant calculations among themselves, not one, not two, but they come up. I usually tell the students that you should come up on the board. Go to the chalkboards, you calculate, and then you will reach in the paper and you are confident enough, confident that you have gained through discussing with other fellows. That one is enough to make you pass and get a good score in that math paper. Then we also have the other topic of curve sketching. You find students having very many issues with it. So students, I urge them that they should try by all means because they are always simple things. They also just need to draw the graphs like that. So that's my submission.
Thank you so much, Teacher Peon, for the submission and for those wonderful tips to the candidates. Okay, we are back to you, Teacher Samuel.
Yes, thank you so much. I apologize. There has been technical problems, so it put me off. But I'm back. I think we are now going to question 2. And thank you for the input. I have had someone came in, and that was really important. And thank you for those hints. And that's why I said there's need to collaborate. Through collaboration, we can learn a lot. So in question number 2, we want to find the equation of a chord joining 2 points on a curve. And I want to say a chord is a line joining 2 points on a curve. In whichever curve, can even be special curves like circle, hyperbola, parabola, and so on. So this is a straight line, and to get the equation of a straight line, we need the gradient, and we need a known point on the line. But now here they've given us 2 points, so it is from the 2 points that we can determine the gradient, which is given as change in y over change in x. So we have the gradient of AB being 15 minus 3 over 0 minus -2, and we get 6. Now for general point xy on the chord, we can still get the gradient, which is y minus 3 x over x minus -2 equal to 6. We already know the value of the gradient. So when we rearrange this, we get the equation of the line or the chord to be y equals to 6x plus 15. So this is simply geometry of, this is still geometry of straight line. So you can see this is equation of a line. Sometimes they give you equation of a line passing through a point with the gradient known. So that will be simple, which means you are already at the point where I put let x y be a point on the what? On the chord. So you get it from there. So generally, in order to determine equation of a line, you must know the gradient of the line, and you should know a point on the line. If the gradient is not given, you start, that is your starting point. Then that is part A. Then in part B, I hope you are seeing my screen. Part B is saying we should show that the area enclosed by the curve and the chord AB is 4 square units. Allow me make some illustration here. We have to sketch this curve. So when you look at the curve is y equals to 15 minus 3 y is given as 15 minus 3x squared. So for this, we can get the intercept. A simple way to sketch this curve is to remember the graph of y equals to maybe x squared plus c. This is a family of curves. This is a family of curves that looks like this. I want to change the color of my. Okay. We want to change the color. So the family of curve for y equals to x squared plus y equals to x squared plus c is always like this. But when you look at the given curve, we have negative x squared, negative 3x squared, which means it's going to be inverted. So here you simply need to get the intercept. So for the intercept, we equate y to 0. When y is 0, we shall get x to be equals to 15 out of 3, which is 5. And when we take the root of 15 out of 5, we get negative root 5 and positive root 5. So that's where the curve will cut the x-axis. So if this is the curve, it will cut the x-axis here and also here, where here is negative root of 5. On the other side is positive root of 5. So again, when x is 0, y is 15. So the curve, the y-intercept will be here. So you can see this curve is inverted. Like I told you, the simplest, there is no max for drawing this curve using the techniques earlier on. So this is how the curve will look like. This is how the curve will look like. Then we want to get the gradient. Okay, we have already determined the chord. Remember the chord. The chord is passing through negative 2, 3, and 0, 15. And 0, 15, which means the chord is going to run from here to that point. The chord is running from here to that point, and the required area is this small part here. So for the required area, let me extract, assuming it is like this. You need to get a small strip along the x-axis. And when we get a small strip there, we can call the width of the small strip delta x, small change in x. Meanwhile, the height or the length of this small strip, which is rectangular, will be the equation of the curve. Let's call this one y. Let's call it maybe y2, and we call the equation of the chord, this chord, to be y1. So for that case, the length of this small strip will be y2 minus y1. Now the area of the small strip we have taken is what we are calling delta A, element of area. And since this is rectangular, we know area of a rectangle is length times width. That's why we have y2 minus yy delta x. Now, at this point, the one you subtract from the other should be lower within the given interval. Remember, this curve and the chord meet at the point A, B, whose coordinates were given. And now, if we are to find the area of this, the total area will be summation from, because we need to have divided this into equal strips, and that strip will be delta x each from this point up to that point. And remember, here is -2. Those are the values of x, -2 and the origin. That's where they are meeting. So for that case, we now need to integrate from -2 to 0 of the element of the area. But this time, here we have used delta x. As you change this to the integral sign, you must remember to put the x. You don't use delta x anymore. So we can now integrate. We can integrate this when we substitute for the value of the x. We have 15 minus 3x squared, then minus the equation of the chord, which we got to be 6x plus 15. So when we do this and integrate, we shall get -x cubed minus 3x squared. Sorry, the squared to be here. Should have -3x squared here. But in the computation I used it was typing error. So from there, when you manipulate this, you get the area of the shaded part, or the area bounded by the curve and the chord, to be 4 square units as given in the question. So that is for part 2. This area bounded by a curve is called lamina. So sometimes you will see them using the word lamina. Find the area of the lamina. So lamina is simply area bounded by a curve. So that is for part B. We yet have another one, that is part C. Part C is solid of revolution. For part C, we have solid of revolution. Find the volume generated when the area in A above is rotated through 360 degrees about the x-axis. So still, we have our curve. We have our curve like this. So say this is the y-axis, the x-axis like this. Now we have the chord being this, and the area being rotated is this one I'm shading. So that is the area that has been rotated about the x-axis. Our x-axis is this. So when we rotate this through 360 degrees, it means we have moved one complete revolution. So when we move one complete revolution, then we shall get the volume of a solid. But this solid is going to be hollow because this part from the x-axis until the chord is not under consideration. We only rotating the area that has been shaded there. So similarly, here we also take a strip. When we take a strip here, let me use red pen, this red color. Then the width is going to be delta x. Meanwhile, the length is still going to be y2 minus y1, where y2 is the equation of the curve and y1 is the equation of the chord. So we know when we rotate this small area, it will form for us a shape that looks like this. So the shape form is going to be like this. And you can see from here, this is the small strip. This will be delta x. And the radius will stop here. And the radius is going to be the difference between the two equations. And this shape produced is cylindrical. And the volume of a cylinder is given by pi r squared h. Our h now is delta x, that is the height of the cylinder. The radius is the difference between the equation of the two, of the curve and the chord. And from here, we can see when we substitute for the values of we substitute for the equations of the curve and the equation of the line. After simplifying what is inside the bracket and squaring, we get 9x to the power 4 plus 36x cubed plus 36x squared. Of course, 15, this will give us negative 15. This is positive, so the 15 will disappear. So from there, we can now proceed. Let me clear this as we go to the next slide. So we can proceed to integrate this from negative 2 to 0. And when we integrate this, we get 9x to the power 5 divided by 5 plus, remember here was 36, but we are dividing by the highest power of x now, which is 4. We remain with 9. 36 divided by 3, we get 12. So when we substitute for the limits, you start with the upper limit. So you can see we have the upper limit being 0. We substitute there, minus the substitution for the lower limits. And when we simplify this, we get the volume to be 48 pi out of 5 cubic units. So this is another area which is confusing to the students. But when you if you have got the concept on how we generated this integral, it becomes very simple. There is no need to memorize the formula for getting the volume. You just work from first principle, looking at the shape produced, and you determine the volume. So that is for solid of revolution and area under a curve. This is yet another common part which are usually examined. So that is for number 2. Now number 3. Number 3 is curve sketching. Curve sketching usually rarely meets also, and this is usually brought in section B. The number looks simple, but this number carries 12 marks. These are the areas you should determine when you want to sketch a curve. This is a quadratic curve. So for quadratic curves, these are the major areas of concern. 1, we need to determine the intercept. We have to determine the intercept, and the intercept is when y equals to 0. When y equals to 0, we shall have 0 equals to 3 plus 3 out of x times 3 minus x. The denominator will disappear. We remain with the 3x plus 3 equals to 0. And we get x to be -1. Y is already 0. This will give us the point -1, 0. However, when x is 0, then this function, that is y equals to 3x plus 3 over x times 3 minus x, will be undefined, which means this curve does not cut the x-axis. That is the implication. So another area of concern is determining the turning points. Turning point means you should differentiate the function. So we are differentiating y equals to 3x plus 3 over x into x into 3 minus x. And when you look at this function on the right hand side, it's a quotient, and this takes us to the quotient rule. Remember, I said for the quotient rule or the product rules, you can use them directly without stating. And in case that you have forgotten about it, you can simply look at the log book and you get the formula. So when we substitute, this will be v. Remember, we have already expanded this by taking the x inside, so that we have 3x minus x squared. So v will be the denominator, which is 3x minus x squared, then du by the x, which is 3 minus, now u, our u will be 3x plus 3 times the derivative of the denominator, which is 3 minus 2x. So the denominator has to be squared. But at turning point, the derivative with respect to x should be equal to 0. Turning point is also called stationary point. Stationary point. So at turning points, dy by the x equal to 0. And when we equate this to 0, the denominator is going to die off. We remain with only the numerator, which when we expand, we get 9. We get 9x minus 3x squared plus 6x squared minus 9x plus 6x minus 9 equal to 0. So we now need to solve for x. After simplifying this, we solve for the value of x. So, and from here, we have 3x squared plus 6x minus 9 equal to 0. This is a quadratic equation. There are many methods for solving quadratic equations. But from here, you can see this equation can be factorized. And when you factorize it, you get 3 times x minus 1 times x plus 3. And from here, equating each bracket to 0, we determine the value of x. So the first value of x will be -3, and then the second value is x equals to 1. And you need again to take this to the equation of the curve so that you determine the value of y when x equal to -3, and the value of x when, the value of y when x equals to 1. And when we do this, we get y to be a third and y equals to 3. Now we need to go ahead and determine the nature of the turning points. Here we have 2 turning points. So we determine the nature of the turning points. Like for the first case, which is -3, and then y being a third. When you are determining the nature of the turning points, it is even sufficient to use this equation. It's sufficient to use this equation, since this is the simplified form we got after differentiating. We differentiated and got something. In other words, to determine the sign of the y by the x, we need to go back to the derivative of the function. But the derivative of the function simplified, the numerator simplified to this point, to this part here. And denominator is strictly squared, which means denominator will always be positive, provided x is not equal to 1 and x equals to -3. For all the other values of x, the denominator is going to be positive. So it is sufficient for us to determine the sign using the numerators only. And when you look at the first point, that is x -3, when we substitute for any value left of -3, say -4, and we put here, we shall find that this expression will give us a positive number. We are only interested in the sign, so we need to put positive. Meanwhile, on the right, we take any number right of -3, but should be less than 1, because we have 1 on the other side. So when we put this, we get a negative number. Now, when we put x equals to -3, this will give us 0. So negative on the right means that the curve is, the line is slanting from left to right. So it's negative slope. Meanwhile, this is positive slope. At the turning point, the sign of the y by the x is 0. That's why the curve has to be flat at that point. So this gives us maximum at -3 a third. Doing the same for the second turning point, which is 1, 3, we get a minimum. So in case someone has not got this one right and has some concern, you cannot, later on we shall explain further. So we have already determined the nature of the turning point. So you have to determine the turning point, then proceed to determine the nature. So that is the turning point. Those are the second, that is now the second step. The first one was intercept. The second area is turning point. Then another one is you need to get the asymptotes. For rational functions, we shall always have asymptotes. We have here, we have the vertical asymptote. Vertical asymptote is simply obtained by equating the denominator to 0. Or you can use, to obtain vertical asymptote, you can look at where y goes, where x goes when y tends to plus or minus infinity. You investigate where x will tend to as y tends to plus or minus infinity. So in this case, I have decided to use the first one, which I mentioned. Just a matter of equating the denominator of the function to 0. We get x to be 0 and x equals to 3. So this will constitute the vertical asymptote. Meanwhile, for horizontal asymptote, you investigate the function as x tends to plus or minus infinity. Now, before you can punch in the value, you need to divide. Remember, our curve was like this: y equals to 3x plus 3 divided by x into 3 minus x. So when you look at this, the highest power of x, when we take x inside the bracket from denominator, the highest power of x will be squared, will be 2. So we divide every term in here by x squared. That's why we now have 3 out of x, because initially this is 3x. Then plus 3 out of x squared. Then here we shall have 3 out of x minus 1. So as x becomes large, the denominator will be 0. And so we have, now we shall have 0 out of negative 1. And 0 out of negative 1 is 0. That's why the function y will tend to 0. And the line y equal to 0 becomes the horizontal asymptote. So that's how we get the lines of asymptotes. And this is one of the important aspects that you must investigate when you are sketching a curve. That is now the third area. Area number 4, when you're sketching a curve, you must find the region where the curve lies. Now, how do we get the region? First of all, from the curve, which is y equals to 3x plus 3 over x into 3 minus x. From here, we equate both the numerator and denominators to 0 so that we can determine values of x. And when we equate this to 0, we shall get x equals to negative 1. Negative 1. Then, when we equate denominator to 0, we get x equals to 0. And x equals to 3. So we have these 3 values of x. We now need to divide the entire line. The entire line into this. The first one we have negative 1. So negative 1 is here. Negative 1. Then we have 0. And then we have 3. So the range of these intervals are got in this way. Equate both numerator to 0, you get the value of x, and denominator to 0, you get also values of x. Then you divide the line according to these numbers you have obtained. So from here, from any point on this side on the left until negative 1, x is less than negative 1. Then between negative 1 and 0, we have x less than 0. Negative 1 less than x less than 0. Then we have 0 less than x less than 3. Then beyond this point where we have put 3, x, any value here is greater than 3. Now, we come now to the curve. For the curve, we have x. That's why you have this x here. There's x here. So we have this x. So that's why we have it here. That is the first x, this one. Then we have also 3x plus 3, which is the second part. And then we have in the lower part here, we had 3x, 3 minus x, which is this. Y is a combination of these three. That is y will be 3x plus 3 over x times over x times 3 minus x. So when we indicate like this, you now look for any number less than -1, you substitute here. Say you have picked -2. You can pick -2. -2 is on the left of x of -1. Then we get negative. That's the negative we have. Then when you pick any number between, okay, less than again -1, say you're still using -2. When we put here, we still get negative. But when you put -2 here, we shall get positive. So that 3x plus 3, that is negative, divided by negative times positive. We get positive. Negative over negative is positive. So it means for x less than 1, the curve will be positive. The y value of the curve is all positive. So it is above the x-axis. We now investigate for the other region the same way, the other intervals in the same way. And when we do that, we come out with this table where we have y positive, negative, positive, negative. So this is where y should lie. So that is another important thing. So there are 4 main things you must investigate in order to sketch a curve. You start with intercepts, turning points, then asymptotes, and then the regions where the curve lies. The order does not matter. You can start with any. In some instances, some curve will not lie within a given region. So in that case, you will also need to determine that region. This is not an example, so that's why I have not talked about it in this case. So that is for the curve. Then we now proceed to sketch the curve. First of all, we have 2 turning points. We mark the turning point at -3, 1 out of 3, and is maximum. Meanwhile, the turning point 1, 3 is the minimum. Now you need to draw these curves such that this is line of asymptote. The other line of vertical asymptote is x equals to 0. That's why it's not indicated. And also, y equals to 0, which is the x-axis, is yet another asymptote. So in the region from x less than -1, we saw that the curve is positive, so it must lie above the x-axis. Meanwhile, from -1 to 0, so you can now see from here, the curve is going to come down, and in this range, it's going to be, sorry, let me make correction. First of all, this point should be -3. This point is -3. -1 is right here. So between infinity to -1, the curve is positive. So it must be above the x-axis, and there is a turning point which is maximum. And yet the line y equals to 0 is asymptotic. So the curve becomes parallel as the value of y, as the value of x tends to -infinity. That's why you can see this curve as flattened and it's becoming parallel. So if you extend this, you can extend further and it will never meet the x-axis anymore. While here, y, we have x equals to, this line is x equals to 3, is a line of asymptote. Line of asymptotes are drawn using dotted lines. However, for the x and the y axis, they're already bold. So you need not to draw again line of asymptote on them, since all of them are also lines of asymptotes. So in the region between 0 and 3, we have seen the curve is also positive. So it lies above the x-axis and must be asymptotic. We have a turning point here, which is minimum. So it's just a matter of drawing the curve in this form. Meanwhile, for x greater than 3, the curve is negative, meaning it must lie below the x-axis. And the curve is asymptotic to the line x equal to 3, asymptotic to the x-axis. And the curve has no turning points. So as you draw the curve in this region, there must be no turning points. Meanwhile, it will become parallel to the x-axis and parallel to the line x equals to 3. So this is the sketch of the curve y equals to 3x plus 3 over x times 3 minus x. So these are the major areas that you must do when you want to sketch a curve. The shape of the curve within a given interval is, you are going to generate this by instinct. You need to analyze, observe and analyze how it should be. But what you should know, when you get to any region, consider the line of asymptotes and consider turning points, if any. And those are the information that will help you to determine how the curve behaves in a particular interval. So that is one. Maybe before I move away from this case of curve sketching, allow me to say that when they ask you to give a region where the curve does not lie, because we may not discuss this anymore, and in case they bring, they want a region where the curve does not lie, where the y value does not lie. So first of all, assuming this was one of them, and yet this is not, but I'm going to use it as example. Assuming this is one of them, we shall cross multiply. We have y, so we shall have x into 3 minus x equals to 3x plus 3. So then you open this bracket. We are going to have 3yx. Then this time that we shall get minus yx squared. Now we can even as well bring all of this side. And when we bring this side, we shall have negative 3x minus 3 equals to 0. Equals to 0. This is 0. Now we rearrange this and form quadratic in x. So if we rearrange this and form quadratic in x, we shall have y x squared. Remember, this was negative, it has become positive. Then this and that we shall have positive also, plus this will be 3y plus 3 times x. This was also negative. Okay, I mean this will be negative. Sorry, 1 is going to be negative. The first one here is negative 3. 3y x, then this is plus 3 equals to 0. Now, you solve this. Of course, you have the discriminant. The discriminant, which will be y. This is our a. This is our a. So this will be a, b, c. So we know x is negative. X is given by negative b, and our b is this. Negative b plus or minus root of b squared. So it means in this case, our b will be, let me write it this way, 3 minus 3y. This one we square it. Then minus 4. A is this y and c is 3. So this will be times 3. And you make this to be less or equal to 0. Then you will solve for the values of y. When you solve for the value of y, for the interest of time, let me assume values out of this, assuming we have solved this. Assuming we have solved this and found that y equals to maybe -1 and y and we also found that y is equals to probably 4, like this. Now you will need to again divide the entire line into these intervals. You have -1, we have 4. So we shall have here x less than -1, -1 less than x less than 4, and finally x greater than 4. So these are the intervals because you are solving inequalities. So after, if these are the values, you now pick a value here and pick a value less than this and put on the curve. Say this, assuming you get this to be negative and this is positive, say this is negative. So you can see that this curve is only this interval that satisfies. It should be, this is negative, less or equal to 0 means should be negative. So we shall have, let me interchange. We have this to be negative, this to be positive. So it means the correct answer will be between -1 and 4. And that will be the interval for which the curve does not lie. So this is also common. That's why I had to bring it forward. So in case they ask for that, this is the way to go. That's how you can solve this problem. Then later on, you will draw a line of asymptotes within that region on the curve, on the axis. So you will draw the line of asymptotes like this. That is for, this will be for x equals to 4 and x equals to what? -1. Say like that. Then you have to shade this because the curve will not reach this region there. So that is when they have asked for that. They have not asked in this particular case because this curve is different. There are some curves that behave that way. So that is for the curve sketching. That is the highlights I wanted to put forward. So I could say these are free marks. As long as you can investigate all those 4 things I've highlighted and you come out with correct shapes of the curve at each particular interval. So that is for curve sketching, and this one is 12 marks. And when you're conversion with it, you're going to get it right. Then number 4. Number 4 is still algebra, and this is series. We have the question. The first term of an arithmetic progression, AP, and geometric progression are equal. So the first terms for both geometric progression and arithmetic progression is just one number. Then the common difference of the AP is equal to the common difference, the common ratio of the GP. While the second term of the AP equals to the sum of the first 2 terms of the GP. If the sum of the first 2 terms of the AP equals to the third term of the GP, find the possible value of the values of the common difference and common ratio. So that is part 1. And then part 2, we have a boy wishes to build up a triangular pile of toy bricks, so as to have 1 brick in the first row, 2 in the second row, 3 in the third row, and so on. If the boy had 1,000 bricks, how many rows can he complete? And how many bricks has he left? So let's start with the first part. The first part, first of all, we have these 2 series, arithmetic progression and geometric progression. Before coming to the quantities provided, you should have some basic about these 2 series. So we are going to look at those, what you require in order to solve any problem in AP and what you require in order to solve any problem in GP. So for AP, let's start with the AP before we can come to this question. When we are talking about AP, these are the things you should know. You should know the first term. First term. You know the first term. You know the common difference. Let's call the first term A. Then the common difference B. Then you should know the nth term. Let's denote it by UN. UN, which is given by A plus N minus 1 times the common difference, which is B. That is the nth term. Then you should also know the sum of the first n terms. Sum of the first n terms denoted by Sn, which is given by n divided by 2 times, open bracket, we have 2a plus n minus 1 multiplied by d. These are the only thing you require from GP, from arithmetic progression. First term, common difference, the nth term, and the sum of the first n terms. So any question on AP, you must have to apply this. So you take note of this. We shall use them later. Let's go to GP. What do you require from GP? So when we are talking about GP, geometric progression, GP, we also need the first term. Let me denote it by A. We need now what we call common ratio. Remember, common ratio is the division, the ratio of the successive term. Then another thing you should know is the n term also. I can still denote by un, which is given by a times r to power n minus 1. Meanwhile, the sum of the first n terms for GP, denoted also by Sn, will be given by a open bracket r minus 1. This r, you raise it to power n. Let me make corrections there. We have r raised to power n minus 1 over r minus 1. So that is the sum for the first n terms. And still for GP, we have what we call sum to infinity. Sum to infinity, which is given by a over r is 1 over 1 minus r. One minus r. And for you to use this formula, you must check that the modulus of r should be, in other words, r should lie between -1 and 1. If r is greater than 1, then you cannot determine this sum to infinity. So for GP, we have first term, that is number 1, common ratio, number 2, the nth term, sum of the first n terms, and then sum to infinity. So for any problem now, we need to apply these 5 things when we are dealing with the GP, depending on the information provided. So let's now look at our problem. We can from our problem, we let the first term to be a, which means both for the GP and the AP. Our first term is a. The common difference to be d for the AP, and common ratio for the GP to be r. And when you follow the problem, I've already said d, the common difference is equal to the common ratio. So d equals to r. This is an important equation. Then also in the problem, they said the second term of the AP and second term is given by u2 equals to a plus d. Here we shall have 2 minus 1 times d remains 1 d. Meanwhile, the sum of the first 2 terms of a GP denoted by S2 is a, that is the first term, then r to power n minus 1. So we have r squared minus 1 over r minus 1. So by difference of 2 squares, the numerator, the bracket here in the numerator will expand to r plus 1 times r minus 1. So r minus 1 cancel, we remain with a plus r, a times r plus 1. Also, they said the second term of the the second term of the AP equals to the sum of the first 2 terms. So we simply equate this and that. We now equate this expression, we equate this, the one we have obtained here, and this one. And then When we do that and simplify, we see that the common difference is equals to AR. So that is the common difference in terms of first term and but recall that D is also equals to R, but still we shall need this to help us solve for the unknowns D and R. So we maintain as it is. So that is the first part. The question, we call this equation 1. But the question continues and says, the sum of the first two terms of the AP, which is denoted by S2 still, and is defined by this, and we see that S2 is equal to 2A plus D, is equal to the third term of the GP. And the third term of GP is given by AR to power 3 minus 1, which is AR squared. Since S2 equals to U3, we get 2A plus D equals to AR squared. Call this equation number 2. Now, if we replace D by AR, remember in equation 1, putting 1 in 2, we get 2A plus AR equals to AR squared. And from here, A is constant, cancel, we remain with R squared minus R minus 2 equals to 0. This equation can be factorized into R minus 2 times R plus 1. So if each bracket is equal to 0, we get R to be 2 and R equals to negative 1. And for R equals to 2, D is 2, because they said R and D are equal. And for R equals to negative 1, D is also equal to negative 1. So that is for part A. And strictly, as I said, you need those 4 things for AP and the 5 items I listed for GP. Then in part B, we have 1,000 bricks, and they are supposed to be piled. And this is how the piling will be. We should have 1 brick in the first row, 2 bricks in the second row, then 3 bricks in the next row. That is the third row. So we shall have like this. Which means if you make that, because they said and so on, if you make the next row, we shall have 4 bricks. And so on. So when you look at this, the first row has 1 brick. So 1 plus. The second row has 2. The third has 3. And the fourth has 4 in that order. And this gives us an AP with the first term being 1 and common difference also 1. 1,000 bricks to be used, we need to sum up this. We get Sn. We get Sn from which is n out of 2 times 2a plus n minus 1b. But since we have only 1,000 bricks, the sum of all these ones should be less or equal to 1,000. And this, when we rearrange, it gives us this quadratic equation. And using the formula method, we find that n is given by that. And when you solve for n, we get n to be 44.2242 and n negative 45.2242. But here, n must be positive. It cannot be negative. So we eliminate this one here. And when we eliminate this, and n also must be an odd number. So we need to round off. And when we round off, since this is less than 5, we just simply truncate. We chop off from here. So we remain with n equals to 44. So that is the value of n. Now we need to go and check. We need to verify the sum. This sum here, which is given by Sn equals to n out of 2 times 2a plus n minus 1b. So to verify that, now we need to get S44. And when we determine S44, we shall have 44 out of 2 times open bracket 2 times 1 plus 44 minus 1 times 1 equals to, and this one, when you simplify, you get 990. So since this is less than 1,000, if it was more than 1,000, you would come down to the next whole number, which would be 43. But now, since this is already less than 1,000, we take it. So from here, we can conclude that he completed 44 rows. Now the number of bricks left will be 1,000 minus the sum we have obtained here. So we remain with only 10 bricks. So that is for number 4. It is about AP and GP. And this is an application. Usually they like bringing this kind of question. They will give you an AP to work on, then later on they give an application of AP or application of GP. You need to read the question carefully and analyze which series to use. In this particular case, since the series was AP and not GP, we needed to apply AP. So that is for number 4. Number 5 now. Number 5, we are supposed to evaluate this integral from 0 to 3 into of square root of 9 minus x squared dx. And then part B, we want to find the integral of the x over e to power x minus 2. So ideally, when you look at the first part A here, part A, what comes to your mind is change of variable or substitution. So you now need to think of appropriate substitution you can make in order to simplify this expression. And when you look at the bracket, you can transform this bracket into some useful function. And the function that can be used to simplify for us this is the Pythagoras identity. We know that 1 minus sine 1 minus sine squared 1 minus sine squared theta is equal to cos squared. Is equal to cos squared theta. So this identity can help us so much. It can help us so much to simplify this. Let's see what happens to it, to this. So what do we need to do in order to simplify this? Remember, we are going to apply this identity, which means you now need to use appropriate expression that can transform this into Pythagorean identities. So for part A, we need simply to let x be equal to 3 sine theta. So immediately from here, you can differentiate you differentiate the function with respect to theta, we get the x to be equals to 3 cos theta d theta. 3 cos theta d theta, because when we differentiate sine, we get cos, and we maintain the angle. So we can see we need to transform from x to theta. So when we substitute for x, we get 9 minus 3 sine x squared times dx, which is 3 cos theta d theta. 3 cos theta d theta. D theta here. Now, when we open this bracket, we are going to get 9 minus 9 sine squared theta. And when we factor out 9, we remain with 1 minus cos squared theta. I mean 1 minus sine, sorry, 1 minus sine squared. This is sine squared theta. That's when we factor out. And you can see from the previous work, this one is now cos squared theta. And when we get the square root, we remain with a cos theta. But remember, there is another cos theta here. That's why we shall multiply cos theta by cos theta to give us cos squared theta. And when you have trigonometrical function with even powers, when you are integrating or differentiating trigonometrical function with even powers, you use the double angle identity. So the set of identity to use here is called the double angle identity. So for double angle identity, we know that cos 2 theta equals to 2 cos squared theta minus 1. So you make cos squared theta the subject. That's why when you make cos squared theta the subject, you pull out the constant. Remember, this one will give us square root of 9 is 3. This 3 times this 3 is 9. That's why we have 9. Then there will be a half because we shall divide both sides by 2. So the 2 comes down. Then inside we shall have 1 plus cos 2 theta. And when we integrate this, we get theta. When we integrate cos 2 theta, we are going to get a half sine 2 theta from 0 to pi out of 2. How did that one come about? When the limits of integration are given and you are changing variables, you must also change the limits. So how do we change our limits? We have this function x equals to 3 sine theta, and for this particular case, they were given us so we have x here, then we have theta. Now x is 0 and x is equal to 3. When x is 0, we come and substitute here. 0 equals to 3 sine 3 theta. So from here you can see that sine theta is equals to 0. And theta will be sine inverse of 0, which is equals to 0 also. So
Hello. Mr. Ronald, can you hear me? Hello. Mr. Ronald?
Oh, I think we've lost him, eh?
Yeah, we have lost him, but we want to thank him so much for the wonderful presentation. It is coming.
5 more minutes, he's coming back. Let's give him.
Okay, I want to thank the
Just to
schools.
wind
that
up,
have-
wind up that next.
Yes. Okay, can we ask schools that are on, meanwhile, to be turning on their videos? Let me ask Maria Goret Katende. I'm saying Maria Sumpta, if it is possible, feel free to turn on your video. St. Joseph's College, Gulu, kindly talk to us, and we may ask the teachers also to talk to us from those respective schools. Maria Goret Katende, Kakila Secondary, Moyo SS, as we wait for our facilitator to get back online. Okay, I'm seeing Maria Sumpta. Okay, very good. Okay, Maria Sumpta, you can say hello to us. Okay, Maria Sumpta, a minute.
Can you spotlight Maria Sumpta?
Okay, Maria Sumpta is there. Mr. Ronald,
Hello, everyone. This is Saint Mary Assumpta. We want really to thank the facilitator because really we have known a lot and we promise to continue attending. Thank you so much. We are so happy. Bye.
Okay, thank you very much, Maria Sumpta. Moyo SF. Moyo SF, feel free to unmute.
We don't.
We
Okay,
really appreciate the seminar. We have really appreciated the discussion. It was really well off. It was very fine, and we have really learned a lot from the seminar. So thank you very much.
Okay, thank you, Moyo SS. I'm seeing Hope 2023. Hope 23, unmute. Hope 23. Even the teacher can talk to us. Let the madam also talk to us as Hope also talks to us.
Hello.
Hello. Okay.
Hello,
Okay,
I'm
teacher.
back.
Okay.
Sorry. I'm back now. I
Okay,
was
teacher,
almost winding up too.
okay, teacher Pierre, before you conclude, let me ask the madam to first talk to us, then you come and conclude. Yes,
Okay,
madam.
okay.
Unmute.
Yes, we would like to thank you for the wonderful job you're really doing. I know it's helping the students because they're understanding. Though the network of today was on and off, but I know with time we shall cope up. Thank you so much for the great presentation.
Okay, thank you so much, madam. Which school is that?
This is still St. Mary.
Oh, St. Mary's Assumpta.
Yeah.
Okay, thank you so much. Okay, teacher Pio, let's conclude.
Fine. Okay, maybe you give me the sharing right. Okay, thank you. So I was explaining how we can change the limits of integration. So let me illustrate still how to change the limits of integration. First of all, we said we have two variables. Now we are changing from x to theta. You have seen when x is 0, theta is going to be 0 too. But now when x is 3, so we also substitute here x equals to 3. Then we see that 3 equals to 3 sine theta, which means sine theta equals to 1, and theta is sine inverse of 1. And sine inverse of 1 is pi out of 2. Now, this brings me to the point that when you are doing integration and differentiation, you must make sure that the unit of your angle is in radians. That's why you can see my angles here are all expressed in radians, 0 and then pi out of 2. Then we come and now do the integration. We get this. Then when we substitute for the angles, and simplify, then this integral gives us 9 pi out of 4. I think this simplification is now okay. It's just a matter of substituting, starting with the upper limit and then later minus the substitution for the lower limit. So that is for part A. Let me move quickly to part B and we wind up. In part B, we want to integrate this function, and still, when you look at this function, is yet change of variable substitution. So we want to let u to be equals to e to power x, so that the u is e to power x dx. Which means from here you can see that e to power x, remember e to power x equals to u. So e to power x minus 2 becomes u minus 2. So that is how the u minus 2 has come. This u minus 2 here. That's how it has come. Then we shall have u times, which is already a partial fraction. So you have applied the technique of partial fraction to solve this integral. So just like when we split this fraction into partial fractions, all the factors here are linear. So we have the first factor a over the first factor plus b over the second factor. And from here, we get the LCM, and then we do the manipulation. So we see that 1, the numerator is equals to a times u minus 2 plus bu. Now we need to solve for this and find the values of a and b. And one interesting method is to put two values of, since we have two unknowns, just put two values of u so that you can find the values of the constants. Alternatively, you can expand this bracket, collect like terms, then equate coefficient of u to 0 since it does not appear on the left hand side, and then you equate the constant to 1. So that is another method. So when we substitute u by 0, when we put u equals to 0 in this equation, we shall have that the first bracket will have 0 minus 2, while the second bracket is going to be b times 0, which is 0. So we remain with a equals to negative half, and doing the same by putting u equals to 2, we get b to be equals to half. Now we take back, we substitute in the integral. When we substitute, We simplify. The first part is negative natural log of 1 over u, natural logarithm of u, while this is natural 1. This is 1 out of u minus 2. When we differentiate this, we get 1. So that this is a function whose derivative is in the numerator. So it's just natural log of u minus 2. Natural log of u, there should be a bracket here, u minus 2 plus c. So when we pull out, okay, we can rearrange this and substitute back for u. Remember, u, initially we said let e to power x be equals to u. So when we put back u, we shall get this. And when we simplify, we get a half. We get a half natural log of this. Natural log of e to power u minus 2, then minus a half x log to base e is what we are calling natural log. So natural log is written as log to base e. So since we are getting natural log of e to power x is the same as log to base e of e to power x. And this, so if you have e to power x here, the result is simply x. So this is how it has disappeared for this particular part coming to x. So that is the solutions to the problem provided in the questions which were posted earlier on. And that is the end of the presentation of the questions. But what I want to advise is that with the mathematics, you need a lot of practice. And when you are solving problems, you don't solve problems from nowhere. We use definitions, we use theorems, we use properties or identities, and some basic principles, which means under each topic, you should know the basic principles. And two, secondly, every question always have a key. And that's what you can use to, that's what we can use to solve a particular problem. Every question has a key. So you need to identify that key to help you solve a particular problem. So at this point, I want to open the floor for any concern that someone may have. Thank you.
Thank you so much, Mr. Opio, for the wonderful presentation. Dear students, in case you have any question, kindly raise up your hand such that the teacher can be able to help us with the solution. Okay, yes, Ms. Kukiliza Safir.
Yes, can let him unmute. Hello.
For me, I want to ask on the other number of curve sketching, how to find a slanting asymptote.
Oh, how to find slanting asymptote. Okay.
Yes.
To find slanting asymptote. Slanting asymptote usually comes when the numerator may have a higher degree than the denominator. You get it? For example, you may have a curve. Maybe let me illustrate. Let me open my just a minute. Let me open again. Let me share and we illustrate better. So what I'm saying is, for slanting asymptote, the curve, for example, y may be something like this: x squared. Sorry. The curve may be like x squared over x plus 1. In other words, the numerator will have a degree higher than that of the what? Of the numerator. So for this case, you can see when we divide all through by x, when x tends to, as x tends to plus or minus infinity, y will tend to, if we divide this by x, we remain with x, while down here we shall have x plus 1 over x. So when x becomes large, this part is going to be 0, and we remain with a y equals to x. And y equals to x will become now our slanting asymptote, y equals to x. So generally, for slanting asymptote to occur, this fraction here, the numerator must have a higher degree than the denominator. Thank you.
Okay, thank you so much. Any other question? Okay, I think the questions have been exhausted, but I may need to hear from St. Joseph's College Gulu and St. Maria Goretti Katende. I have not heard from you. St. Maria Goretti Katende, if possible, kindly unmute, and St. Joseph's College.
Please, let him unmute.
Okay, I'm failing.
I'm seeing Safiru and up. Safiru, can you unmute, please?
Safir, any other question? Okay. I want to thank Mr. Samuel Opio for the wonderful presentation. Teacher Opio, we are really very grateful, and we want to thank you so much for the presentation, for the time you take on to prepare the presentation and everything. Thank you so much. We are really very grateful, and we want to thank all the schools and the teachers that have been able to connect the students online. Maybe St. Maria Goretti Katende unmute. Yes, and that is something.
We would like to thank Mr. Opio for the facilitation and all the organizers. But again, we have a question about the last number for integration.
Yes.
We are begging for a pardon about the whole number.
About the last number, that is the integration. Let me see. That's number 5. Both part A and B. Hello?
For both part A and B.
Okay, for both part A and B. So for part A, let me go back to the sharing. Let me go back to my slides. Okay, we are here. Now for part A, where we have square root of 9 minus x squared. Plainly, you cannot integrate this function unless you change it into a simpler form. So one of the ways by which we can change this into a simpler form is to let 9 minus x squared to be equivalent to some constant, let me call it a squared, into 1 minus sine squared theta. We already know from Pythagorean identities that 1 minus sine squared theta is equal to cos squared. So from here, when we open the right hand side, we shall have here a squared minus a squared sine squared theta. From here, since this is equal to 9 minus x squared, it means a squared equals to 9. And definitely you can see that this will give us a to be equals to 3. Also, x squared equals to a squared sine squared theta. So when we take square root, you can see that x is going to be equals to a sine theta. But a is already known. A is equal to 3. So this is 3 sine theta. That's how you can, when you are changing variable, you let x to be this. That's how we generate it. I made a shortcut to make this one here, but this is how it is generated. So from here you get, from here you can get, the y by the x. You get the y by the, you get the x in terms of theta, which is going to be 3. 3 is constant. If we differentiate sine, we get cos theta. So by doing this substitution, you will simplify. When you do this substitution, it will simplify for you this integral. It will simplify for you the integral to a simple number or a simple expression that you can easily integrate. And remember, we have seen when you differentiate sine, you get cos, which means if you integrate cos, when you integrate cos, this part here, when you integrate cos, this part, you should get sine, and you maintain the angle. This angle, the angle is 2 theta. But when you look at this angle, it has two here. So when you are writing the integral, you need to first differentiate this part. And when we differentiate this part, we get 2. So you put 1 out of 2, then sine 2 theta. You maintain the angle. So that is for part 1. That is for part one. That's what you do. That is part A. If we are to integrate, then we get this. Remember theta, this one is 1. If you integrate with respect to theta, it will give you what theta itself. So that is for part A. I think it may be better now. Then for part B, we have this. Remember, this is just the same as 1 over e power x minus 2. Then the x. When you look at the numerator, remember we know the integral of this. If it was simply e to power x, this is exponential function. When we integrate this, we get straight away e to power x plus 1, plus c rather, plus c, constant of integration. But now, the lower part here, you can see there is e to power x minus 2. And therefore, we have to transform this. We need to transform this into something which is easy to manage. In this way, it's not easy yet. So one of the techniques you can now apply is to change the variable from x to another variable, probably u. And we can let this exponential part to be equal to u. That's why in my presentation, I had to let u to be equals to e to power x. Someone may think that let me change this variable and let this time let u to be the whole of this lower part here, e to power x minus 2. So from here you can even see du is going to be e to power x dx. So still if you have used this method, this one may also work out. It means the integral now will be 1 over, we are letting the whole of this to be u times the x, but our dx is going to be du over e to power x, which means from this part you should make e to power x the subject, and when we make e to power x the subject, we shall get, making e to power x the subject, we shall have du over u. Making e to power x the subject means we take this one the other side, we shall have u plus 2. So this is yet partial fraction, and when you do this, you will still get the answer. You will still get the answer right. So there is option here. You can either let u to be this part, or you let u to be the whole of this denominator. Then you simplify it. It gives you partial fraction, and this partial fraction also has linear factors. So you express it still in this form, but here will be plus. You will get different values of this constant a and b. Then later you will integrate and you get the answer. So that is what I can add about these two numbers, or these two parts. Thank you.
Thank you so much. Let me hope Maria Goretti, you have understood how to go about that number. Maria Goretti, kindly unmute and you let us know whether things now are clear.
Thank you so much. The things are clear.
Yes, you're welcome.
Okay. Okay, that is very good. Thank you so much once again, Mr. Pio. We shall use the same links because I know on Friday we are likely to have the paper 2 math, but
Yes.
we should still continue to meet. And once you finish your mocks, we shall have a holiday where we are going to have topical sessions and we shall be using the links. So as students, we want you to keep these links that we are using, keep them such that when we go back in the holiday, we can maintain our program such that by the time we go for our final exams, when we are really ready and when we are set to only score A's. We want to thank you so much, Mr. P, once again, and I'm sure we shall have you during the holiday to have those topical sessions for our candidates such that they can shine as we close the journey.
Okay. I want to just say, first of all, let me apologize because my connection has been on and off today. I apologize for that. Secondly, I want to say that my contact is there. Anyone who wants to contact me, please feel free. Feel free, you can give me your concern. More specifically about paper 1, that's where I have my expertise. So any question on paper 1, you can just ask, I will be able to respond. And I would like to wish every candidate success. I've already seen some regions have already done their mathematics paper 1 and 2 yesterday, and Kole region already did theirs. So for the remaining regions that are yet to do their mock examinations, I urge them to continue practicing until the end, and I would like to wish them success. Thank you so much for attending my session. We shall keep in touch.
Okay, thank you so much. Allow me to welcome Mr. Ronald Dungu to say something and finally call off the session.
Mr. Kaziva, Mr. Kwikiriza had a school. I don't know if he opened his video for us to see, but he said that he had a school in Mbirizi. Mr. Kwikiriza, are you still there?
Yes, I'm there.
Have the students left?
No, they are here.
Mr. Kaziva, can you check on the students in Mbirizi? That is excellent.
I want to first stop the, okay. Wait. Okay, just a minute.
Mr. Kwikiriza, we had requested that you keep taking photos of any session so that you share with us and we see the students. That is very exciting. Dear students, can you wave to us?
Yes, ma'am.
Okay. That is very good to note that we are in Mbirizi also. And for the earlier questions asked, I want to thank everybody who has been on this call. Sorry that we are ending late, but that is the passion of study. And we thank Mr. Pio for accepting to lead us today. We'll continue with the rest of the programs tomorrow up to Friday, and then we'll pick up as Mr. Kaziva has guided. There will be some sessions in the holidays, but also after you return to school. I want to thank everybody who has been on the call, Mr. Kaziva and your team and all our partners. Thank you for making this possible. And I want to declare this session closed for today. Thank you.
Okay, thank you. Bye-bye and good night.
Bye-bye.
Yeah.
It's a beautiful photo. Let us first take that one from St. Mary's. Katende, don't remove.
Yes.
There's a beautiful photo I want to take for Maria Goret Katende. Okay, thank you so much, teacher, for connecting. Thank you so much. Bye-bye.